Hello, this is question 5 on your November 2021 paper 3 from AQA. It's a Radians question. So you have flower beds in the shape of sectors of circles, like this one. And they say they are going to put an edging strip around, and the price per meter is £1.80. One of the flower beds has a radius of 5 meters, an angle of 0.7, and we have to find the area of the flower bed. So remember, when we have a sector and the angle is in radians, the area is going to be 1/2 radius squared times by the angle in radians. So in this case, it's going to be 1/2 times 5 squared, which is the radius, and the angle 0.7. So as simple as that is 8.75 meters squared. Yeah, if you have units, I would recommend you to write the units always. Then the next one says, find the cost of the edging strip required for this flower bed. So the edging strip goes all around. So what we are going to do is to find the perimeter and then multiply by 180. And the perimeter is going to be the arc length and 2 times the radius, because I have one radius here, one radius here. So the perimeter is going to be the arc length, when it's in radians, is r theta. And then I have 2 more r's on the side. Yeah, so this is going to be 5 times 0.7 plus 2 times 5, and this is 13.5 meters. This is the perimeter, which means the cost is going to be £1.80 times the perimeter. Yeah, so it's £1.80 times 13.5, which is 24.3. It's pounds, so I'm going to add the pounds, and I'm going to add a 0, because it's how we write the pounds. Yeah, that's it. The next thing, it says a flower bed is to be made of an area of 20 meters squared, and we have to show that the cost has this expression. This expression is only in terms of r. Yeah, not the angle. So let's going to see how we can write an expression. We say the cost is going to be £1.80 times the perimeter. Yeah, we said before, that's what we decided before. And the perimeter has this expression, is the arc length plus 2 times the radius. So r theta plus 2r. But we don't want theta in our expression, so what we are going to use is this information to eliminate r. If the area is 20, we know the area, we say, is 1/2 r squared theta, which means when the area is 20, I have 1/2 r squared theta. So I can write theta in terms of r, and theta is going to be 20 times 2 divided by r squared. So if I go back to my expression of the cost, so here, and I'm going to go down, I'm going to have that 1.80, so the cost is going to be 1.80 times r times 40 divided by r squared. I'm only substituting theta, which is 1.80 times 20 divided by r plus 2r. If we compare this with what we need, it's quite similar already. I have, sorry, I don't know why I wrote 20. This is 40. We have a very similar expression. This has been divided by 2, and the 2 goes outside. So I have something like 3.60 multiplied by 20 divided by r plus r. So my bracket is already the same. I just have to write the 3.60 as 18.5. But if you think of a fraction, so if we have 3.60 and we want to write it as a fraction, is 36/10, and when we simplify, it's just 18/5. Yeah, so 3.60 is the same as 18/5. So this is the expression that we want. Is 18/5, 20 divided by 2 plus r. And it comes from the perimeter formula, and then substituting the angle in terms of r. Yeah? So that's the expression. Then it says, hence, so we are going to use that expression showed that the minimum cost of the aging strip for the flower beds occurs when R is 4.5. So we have to find the minimum cost. To find the minimum cost, we are going to differentiate the cost, and we have this expression here. To differentiate it, we can differentiate it like it is, or we can maybe multiply the coefficients, because maybe you find it easier. Yeah, so we can rewrite the expression. If we multiply the coefficients, we have something like this. Just expanding the bracket, yeah, just in case it's easier for you. And to differentiate, again, the R in the denominator can be written like this, and again it's easier to differentiate. Yeah, so if we differentiate this expression, we have minus 72r to the power of minus 2 plus 18 over 5, and that must be 0 if I want the minimum. So that means that that expression here, if I come back, I have that 18 over 5 is going to be 72 divided by r squared, which means that r squared is going to be 72 divided by 5 and multiplied by 18, which is 20. And from here, r is going to be root 20. Root 20 is 4.47 something, which is, or can be approximated by 4.5. Yeah, as we have to prove. It says justify fully your answer, which means that we should prove that this is a minimum. It could be a maximum. So let's going to find the second derivative. So we are going to derivate again, and we are going to show that this is a minimum. So the second derivative, if we use this expression here and derivate it again, we have minus 2 times minus 72. Yeah, so I have minus 100, no, plus 144 r to the power of minus 3. And this is going to be always positive because r is a distance and is going to be positive. So if it's positive, that means this is going to be a minimum. And this is what we have to prove. Yeah? And that's all with this question.